All right. Now that we've talked about polynomial and rational functions for a bit, we're going to take a short break from our discussion of functions, and we're going to talk about inequalities. Um, Inequalities come up from time to time in a calculus course, and for us, the main place where inequalities are going to show up is when we're looking at graphing functions. We're going to be constructing various sign diagrams. We're going to want to know, when is our graph above the x-axis, when is it below, when is our function increasing, when is it decreasing. There are all these things we have to look at that involve kind of working out when certain function values are either positive or negative, when is one thing bigger than another thing. And so we often need to work out inequalities involving functions. Now, the basic rules for inequalities, I'm just going to run through this quickly. You can always pause this slide if you want to kind of look things over. The first thing is this reminder that the real numbers are ordered. They're what's called totally ordered, meaning you have this usual number line picture, right? So the numbers are arranged from negative to positive in this number line, right? Somewhere in the middle is 0. And we have this ordering, right? So if you pick any two real numbers, you can always compare them and tell, okay, are they equal? No? Okay, then one of them has to be bigger than the other, right? So you can always figure this out. Now, this ordering is what's called transitive. That's this property here, meaning if I know that A is smaller than B and B is smaller than C, then it must in turn be true that A is smaller than C. And then we also kind of have some basic properties telling us how does this ordering work when you're doing arithmetic, right? So if you have one number which is smaller than another and you add the same quantity to both of those values, well, the quantity on the left will still be less than the quantity on the right, and so on, right? So we have these various properties telling us about ordering. One that you probably want to be careful of, and this is again a source of mistakes, is this guy here, right? You can multiply inequalities by a constant, but not all constants are created the same. And the big part here is this bit, right? If you want to multiply both sides of an inequality by a constant, well, check to make sure it's positive, right? So for a positive constant, you preserve that inequality. But if you multiply by a negative, the direction of the inequality switches around, right? You reverse the inequality. So you got to be very careful multiplying because you might switch that order, which can get you into some trouble. Also, you can say certain things about, say, squaring and reciprocals, but there again, you got to be careful because these are things that really only work when you're dealing with positive quantities. If you're not careful and you try to apply certain things that you think should be true when there are negative numbers involved, you can get yourself into trouble. Now, another function that comes up from time to time, and this seems as good a place as any to mention it, is the absolute value function. The absolute value function can be thought of as measuring kind of distance, right? If I have 0 here and I have a number A over here, or it's a negative over here, right? Both of those numbers are the same distance from 0, and so if I want to think about distance is always a positive quantity, right? You never talk about a negative distance. So the absolute value is simply a function that takes a number and strips the sign. So if you feed it a negative number, it changes the sign to make it positive, right? So notice here, in this definition that if x is negative, right, you see that minus sign and you think negative number, right? But if x itself is already negative, putting that minus sign out front actually turns it positive, right? So if x is equal to like minus 5 minus 5, that's plus 5, it's positive again. I put this little warning in here, square root of x squared. A lot of you think it's going to be x. Again, this is one of these things where if you're not careful about negatives, things can go wrong on you, right? Because if you take a negative number and you square it, that comes out to be a positive quantity. Take minus 4. If I square minus 4, I get 16. What do I get when I take the square root of 16? I get plus 4, right? I don't get back to minus 4, I get plus 4, right? Square root always denotes the positive square root, right? So there's no plus or minus that's built into that function. If there were, it wouldn't be a function anymore because it would have two values. So I thought I'd throw that in there just to kind of give you a heads up. That's a mistake that some of you are probably going to make at some point if you're not watching it. Okay. Some properties of the absolute value as it relates to inequalities. I've thrown them in here for reference. Again, you can pause the video if you want to take a little bit of time to think about these, but I don't want to dwell on them right now. I want to move on to kind of the sort of inequalities that you're going to find yourself solving more frequently in this course. Simplest case, linear inequalities. Here, not too much can go wrong. You're basically using those rules that I posted on the first slide, right? Using these algebraic rules for working with inequalities. So what can you do? Well, we often, our habit is maybe to collect, x's on the left, numbers on the right. So let's say we do that, right? So what would I do? I could subtract 5x from both sides. So 3x minus 2 minus 5x would be less than 1. I subtract 5x from both sides. And then I can also add 2 to both sides, get rid of that 2, right? So first let's combine these. So 3x minus 5x minus 2x, well, that's going to be less than 1 minus 2, so 1 plus 2, which is 3. Here's where you got to be careful, right? My coefficient is a minus 2. I want to get rid of that minus 2, so I'm going to multiply both sides of the inequality. So I'm at here. I've got minus 2x is less than 3, and I want to multiply now by minus 1/2. Well, okay, if I do that, that's a negative number I'm multiplying by, so I have to switch that inequality around, right? Multiplying by a negative reverses the inequality. Now I get x is greater than minus 3 over 2, and I'm done. Of course, the other way I could have done this is I could have subtracted 3x from both sides and subtracted 1 from both sides and got to minus 3 is less than 5x minus 3x, so minus 3 is less than 2x. Then divide both sides by 2. 2 is a positive quantity, so I don't have to worry about dividing by 2. And of course I get to the same place, right? So linear inequalities are pretty straightforward. Really the only thing you could mess up is if you forget to switch the sign around if you end up multiplying by a negative. The trickier ones are once you get into polynomial inequalities, rational inequalities. Here's an example with a quadratic inequality. How do I solve this guy? X squared minus 5x less than 6. Well, there's not a lot you can really do with it as is. You got to move some things around. You might be tempted to maybe factor that left-hand side as it is, but that's not going to work, right? And then you're trying to figure out when is a product going to be smaller than 6. That's kind of tricky. The right thing to do with any kind of inequality that's more complicated than linear is to get everything on one side and compare it to 0. So you're trying to figure out when is something positive or negative. So if I subtract 6 from both sides, x squared minus 5x minus 6 is less than 0. Oh, I'm going to get myself in trouble here. I don't think I can factor that. Can I? I'm going to cheat, guys. I want to make this into an easier problem so we can get somewhere. Let's make that minus 6. So this is plus 6. I'm changing the problem because I want the numbers to come out nice. I don't want to have to pull out quadratic formula on you guys. So you move everything over to one side, and then you factor. I happen to know that this factors as x minus 2 times x minus 3 less than 0. Okay? So now I'm in business. Why am I in business? Because I'm trying to figure out when a product of two numbers is negative. Well, what's the only way that a product of two numbers can be negative? A product of two numbers is going to be negative if one of the two numbers is positive and the other one is negative, right? If they're both positive, that product is positive. If they're both negative, the product is positive. So how do I figure out when one is negative, one is positive? What we do is we draw a little number line. So this is called a sign diagram. So what we do is we draw ourselves a number line. and we mark off our zeros. We look for where are the places where one or the other of our factors equals 0. Well, the first factor equals 0 at 2. The second factor equals 0 at 3. Okay. Now maybe we'll do this as sort of an intermediary. It's kind of x minus 2 in red, x minus 3 in green, and let's think about the signs in each interval. So x minus 2. If x is smaller than 2, x minus 2 is negative. Okay? Right? I'm subtracting 2 from a number that's smaller than 2. If x is bigger than 2, it's positive. So it's positive here, it's positive here. X minus 3, well, it's negative if x is less than 2, and it's still negative if x is less than 3, right? Anything smaller than 3 is going to give me a negative value there, but once I cross 3, it's going to be positive. And now I look at each of the three cases. For all values less than 2, I notice that both of my factors are negative. If I multiply two negatives together, I get a positive sign. In the middle here, I get positive times negative. I get a minus sign. Out past 3, positive times positive, it's positive again. Okay. So I look at this, I say, all right, the only place where it's negative is in between 2 and 3. And so that means that I need x to be between 2 and 3. The other way we could say this in interval notation, we could say that x belongs to the open interval from 2 to 3. Okay, so this is kind of a standard procedure. You want to collect terms, factor, sign diagram. This will work for any polynomial function. It will also work for rational inequalities. Now here is one case where you can very easily go wrong, right? So one of the temptations that people will have with a rational inequality is say, hey, I'm going to take this rational inequality, I'm going to turn it into a polynomial inequality. We just did that polynomial example. We know how polynomials work. So let's multiply everything by x plus 2. And then I'm rid of my denominators, and I'll go from there. What's wrong with that? I don't know what x is. X could be bigger than 2. It could be smaller than 2, or smaller than minus 2, rather. So x plus 2 could be positive, could be negative, depends on the value of x. And if I wanted to multiply everything by x plus 2 to get rid of the denominators, I would have to kind of break things down, and I have to consider two cases. Case 1 where x plus 2 is negative, case 2 where x plus 2 is positive, because in the case where it's negative, I've got to worry about reversing the sign of that inequality, right? If I multiply both sides of the inequality by a negative number, it switches. So how do you get around this problem? Same thing as before. We start by collecting terms, and so we say x plus 6 over x plus 2 minus 3 is bigger than or equal to 0. What now? Well, I can combine these three terms on the left if I get a common denominator. So I'm going to go x times x plus 2 over x plus 2, 6 over x plus 2 minus 3 times x plus 2 over x plus 2. And I haven't actually multiplied both sides of the inequality by anything. I'm just rewriting these two terms, the first and the last term here. I'm rewriting them as equivalent fractions, right? So I haven't changed anything. I can do this. And now, because the denominator is the same in all three terms, I can collect them up. I've got x squared plus 2x plus 6. Careful, that minus pushes through. Minus 3x minus 6. And the whole thing is over x plus 2. That should be bigger than or equal to 0. Clean things up. I've got x squared minus x over x plus 2 bigger than or equal to 0. And so let's factor that top. X times x minus 1 over x plus 2 needs to be bigger than or equal to 0. So now again, the way we finish things off is we go to a sign diagram. We say, what are our sorts of points of interest here, right? We have kind of this number, we have x times x minus 1, and then we divide by x plus 2, right? So again, three numbers being combined, depending on the signs of those three numbers, the outcome is going to be either positive or negative. And so we mark off the places where each of those terms switches sign. X plus 2 switches sign at minus 2. I'm going to put a hollow circle there to remind myself that I can't actually allow x to equal minus 2 because I can't divide by 0. The top is equal to 0 when x equals 0, and it's equal to 0 when x equals 1. And now I kind of work my way through, and in each one of the four intervals that I have, I say, okay, what's the sign? If x is bigger than 1, everything here is positive, so the whole thing is positive. What about between 0 and 1? Well, between 0 and 1, this is positive, but that's negative. I've got one minus sign. So overall, the whole thing is negative. What about when I'm between minus 2 and 0? Well, this is still negative, but now this is negative too, right? Because, oh, sorry, I mixed things up, right? X minus 1 was negative here, x was positive. Less than 0, this is negative, this remains positive, so I have two minus signs. Overall, it's positive. And once I get past minus 2, all three of my terms are negative, and if I have three minus signs overall, that means the whole thing is negative. So I look at that, and now I come back and I say, what did I need? I need to know where it was bigger than or equal to 0, right? I want to know where it's positive. I'm looking for the plus signs. So where is it bigger than or equal to 0? So my solution is going to be that x belongs to, now I have to leave out minus 2 because my inequality isn't defined at minus 2, but everything from minus 2 up to 0, and then everything that's bigger than 1, so from 1 up to infinity, okay? And that gives me the answer. And feel free to see what happens if you had kind of multiplied everything by x plus 2. You'll find that you don't get the right answer. Okay, you'll mess things up if you do it that way. Okay. So that's all we want to say about inequalities for now. We're going to move on in the next video and talk about exponential functions.